So this example that you were going to try is pretty tricky, but we decided that we were going to do the pathway OX, we were going to do it in two different ways. We were either going to travel along this green pathway, which I'm now going to use the blue pen for part A of the question, or the other way that we decided we could do that pathway was to go down here and then up here like this, which I'm doing in red, which is what I'm going to do instead of the yellow for part B, just because if I write in green and yellow, you won't be able to see what's happening, okay? Now, this bit maybe is sounding confusing, but in the previous question, we had to introduce lambda and mu, but they've just told you what lambda and mu are actually going to be used for. So it's slightly different. They've told you how to use them, but we need to be able to just use the information they've given us. So part A is actually a very short one. It just says, find an expression for OX in terms of AB and lambda. Well, if OX is just lambda of OC, then it is just going to be lambda of whatever OC is. So I'm going to need to know what OC is. OC is what? A plus B. It is just A plus B. So I've written that up there because I'm going to use it. And so part A of the question is already finished. It is just lambda A plus lambda B. Done.
Leave it in the brackets.
You could leave it in the brackets as well. Yep. You can leave it in the brackets or you can leave it like this. It doesn't matter at all. Now I'm going to do part B, which I'm going to do in red because it's going to correspond to this other part of the journey. But they've said that if Bx is some kind of fraction of BQ, so that's really just saying that Bx is some fraction of BQ. We don't know what it's going to be split into. In the previous question, they were split half and half. This one, they're not going to be split half and half. So what I'm going to do is I need to find out what BQ is so that I can find out what Bx is. So BQ, what is BQ? Good. BQ is minus B plus a third A. So that's minus B plus a third A. I've just written them that way around because it makes sense to start with A, especially when A is positive and B is negative. So that's what BQ is equal to. So for part B of the question, we're also going to find an expression for OX. Now we know that OX for our journey is going to be B plus Bx. So that's B plus Bx. But we also know that Bx is mu BQ. And that is mu BQ. And I also know that BQ is a third A minus B. So I'm going to expand the brackets. So I get B plus a third mu A minus mu B. What did I do on the previous example here? What did I do on the previous example to this? Factorized, good. So I'm going to see if I can factorize this without rewriting it. I'm going to start off with a third mu A. What would it be for B? What are these factorized to? 1. 1 minus mu. I've got 1b minus mu. Now remember what we've calculated. This is what OX is equal to. This is what OX is equal to. I've done part A and I've done part B. I'm going to do part C in black pen now. I'm going to compare coefficients or otherwise, but we're going to do comparing coefficients. We're going to find out the value of lambda and the ratio OX to XC. Well, let's just follow the same pattern that we did before. I'm going to make this blue bit equal to this red bit. So lambda A plus lambda B is equal to a third mu A plus B 1 minus mu. And we did previously, we highlighted bits and said what was the same. So I know that lambda and a third mu must be the same as each other. And I also know, I don't want to use the yellow, but I will. Very good, and that lambda is also 1 minus mu. And then what did we do with these things?
You substitute, since lambda equals 1 minus u, you can say a third mu equals 1 minus u.
Yeah, I'm really solving these simultaneous equations, and Abu gave me this bit that it's going to be a third mu equals 1 minus mu. So I'm going to add mu to a third mu. What's a third mu plus mu?
4.
Good, 4 over 3 mu equals 1. So I can multiply by 3. and then divide by 4, so that mu is equal to 3/4. But they actually wanted us to find out what lambda is. So I'm going to use the fact that mu is 3/4. I know that lambda is 1 minus 3/4 or a third of 3/4, which is a quarter. So I can either do 1 minus 3/4, which is a quarter, or a third of 3/4, which is a quarter. So lambda is a quarter. Let's just go back to what the question actually is saying here. So we're saying that lambda is a quarter. Lambda is a quarter. That means that this green section of the line here is a quarter of the whole line. And it also means that mu is 3/4. Mu was referring to BQ. So it's saying that BX is 3/4 of that long line that we've got there. Which is kind of cool. For any parallelogram, whether it looked like this or whether it was a parallelogram that looked like this, if we had these things split in that particular way, it will always be that will be a quarter and that will be 3/4, no matter what the parallelogram looks like. Okay? So the ratio, we're going to finish off, OX to XC. Well, we know that this is a quarter, because that's what lambda was, and this is 3/4. So OX to XC, we can either say that it is a quarter to 3/4 and multiply both of them by 4, so we get 1 to 3. And I'm going to ask for something extra that the question hasn't asked for. I would like to know what is the ratio BX to XQ. Well, we know that BX, this was 3/4 because mu was 3/4. And then this would be 1/4, so it's 3/4 to 1/4. It's 3 to 1. Okay? I know it's cold because of the window. I'm going to try and I'll turn the heating up. Now, if the question didn't give you part A and part B, if they just said find out the ratio OX to OC, you might not have wanted to call this section over here mu. I probably would have called this section over here mu. I would have probably just done this journey, and then for the yellow journey, I probably would have just done this one and this one. But it doesn't matter. They called this one mu, so we had to do it in that way. We could, if we wanted to, have called this part, this section mu, and we could have done it the other way around. So we're going to do some of these questions in class. We'll do a bit of practice, a little bit more practice on them, and I think you definitely need to watch these again. Yep, I'll scroll down here. So the questions I think we're going to have a go from exercise 11E. We're going to try question 1, 3, and 4. Now remember, these questions aren't going to be identical to the one I've just done. They may be similar to this GCSE style problem. Okay, so it's not just because we've done something hard, please don't just repeat the same process for whatever the question. Make sure you read the question and now think, okay, which kind of skill am I going to be using?